This course is about installing a residential irrigation system. We'll walk through the entire process, gathering the materials, measuring and flagging the job site, installing pipe, wire, sprinklers, and valves, making the connection to the water supply, installing the controller, and wrapping up the job. A good installation begins with an accurate material list based on the system design. To prepare a material list, start by making a count of major components like heads, valves, and controllers. Pay attention to details like sprinkler type, nozzle size, and valve size to ensure that you know exactly which parts you need to order. Next, count up the total footage of pipe. For each size and type, keep a separate tally. If you have a scale drawing, you can use it to measure the length of each section of pipe and add all of the sections together to come up with the total length. For instance, if the scale in your drawing is every quarter inch equals 1 foot, you know that 1 inch on the drawing equals 4 feet. Therefore, if you measure 28 inches of pipe on the drawing, you will need 28 times 4, which is 112 feet of pipe. It's a good idea to add about 5% to accommodate any changes to the plan on site. So multiply 112 by 1.05 to get 117 feet of pipe. Round up to the nearest stock length, typically 20 feet for PVC and 100 or 300 feet for polyethylene, to determine how much pipe to order. If there is a drip zone on the project, measure the required amount of drip tubing in the same way. Remember to include pipe for any sleeves going under sidewalks or driveways. In addition to ordering pipe, you will need fittings. Here are some things to look for in the plan when counting fittings. The location of valves. At each valve, you will connect it to the main line with a T, manifold T, or elbow. You'll also need fittings for the outlet side of the valve leading to the sprinklers. Look for T's, 90-degree turns in the pipe, crosses, or other changes in direction in your plan. Count these and note them on your material list. Identify the fittings needed to connect to the sprinkler heads, including T's, saddles, and end-of-line fittings. Also include the riser assembly for the head, which can be a pre-made swing joint, a fixed riser, or simply a couple of feet of swing pipe with the swing barb elbows. Remember, spray heads and rotary heads use different sized connection fittings. Plan fittings for the point of connection to the municipal water supply, including the backflow preventer, drains, if any, and shutoff valve. If there is a drip zone on the project, count fittings for the drip zone, fittings to connect to the valve, and rounded staples to secure the drip tubing to the soil. Next, determine how many valve boxes you'll need for the system. Depending on your preference, you may wish each valve to be placed in its own valve box. In some cases, when valves are grouped together in a manifold, they can be placed in a single large valve box. Plan your valve box selection to allow for easy access and servicing of the valves in the future without the need for more digging. The National Uniform Plumbing Code requires all irrigation systems connected to municipal water supplies to be protected by a backflow preventer. Consult with your local plumbing inspector or water authority on the type of device required in your area. If the device will be installed next to a building or in a landscape, use of metal or copper pipe for the above-ground connections is preferred for longevity and aesthetics and may be required in certain areas. Some areas require all connections upstream of the backflow preventer to be installed by a licensed plumber. Be sure you understand your local requirements before starting the job. Order the irrigation controller type, indoor or outdoor, based on the installation location, and select a model that can control at least the number of zones on the plan. For outdoor controllers, you should plan for appropriate weatherproof conduit to bring cables to and from the controller. For indoor controllers, plan to mount the unit close to an existing wall outlet and make a list of the conduit and supplies needed to route the zone wires from the yard into the interior location. When choosing wire for a typical residential system, many contractors use multi-stranded wire, which wraps a number of strands of wire into a single jacket. Now, if you have a 6-zone system, you will need 7-strand wire. 1 strand for the common wire that connects to each valve, and one strand for each zone. In other instances, you may wish to run individual wires to each valve. Order wire splices that are rated for direct burial. 2 will be needed for each valve. Here are some additional supplies you may want to have on hand: Teflon tape, duct tape, flags for marking head locations, waterproof wire connectors, conduit for the controller, primer and cement for PVC pipe, marking spray paint, and gravel to line the bottom of the valve boxes, if desired. Make sure you have the tools necessary for installation, including square spades, shovels, trenching shovels, a trencher, or a vibratory pipe puller, depending on local soil types and preferences, power drill for the mounting of the controller, hammer drill and bits for through-wall connections, copper pipe cutter for the point of connection, pipe cutters and saws, wire strippers, a volt-amp meter for troubleshooting, slip joint pliers for tightening connections, a sprinkler adjustment tool with a small screwdriver, a sledgehammer and a sidewalk sleever or a jet nozzle for sleeving under sidewalks, and rakes and brooms for cleaning up. Before arriving at the job site, be sure to call 811 or all of the local utilities to have utility lines marked. Avoid using mechanical equipment to dig near buried utilities. These areas will be strictly hand dug. Also ask the property owner about the location of wires to exterior lighting fixtures, drainage lines, gas pipes to outdoor grills or pool heaters, and other yard utilities. The first step in installing the system is to mark the location of sprinkler heads with flags and the location of the valve boxes, often done with some spray paint, on the property. Transfer the design from the plot plan to the yard by identifying anchor points like the corners of the yard or house, and then transferring the measurements from those anchor points to the location of valves or sprinklers. When there are several sprinklers evenly spaced along the border of the property, use a measuring tape to ensure that they are evenly spaced according to the design on the plot plan. Once you have located all of the sprinkler heads and valves, you will need to determine a route for the pipe. This will be based on the plan, of course, but as an installer, you may need to make adjustments for on-site obstructions, including utility lines, sidewalks, driveways, and trees. Keeping pipe outside of the drip line of established trees will minimize the need to cut through roots, and, for instance, running the main line all the way around the house can eliminate the need to bore under the driveway. When making plans to route the pipe, also consider where you want to route the wire. Laying the pipe and wire in common trenches saves time and ensures that your wire is handy at the location of the valve boxes. When routing the wire past the location of the valves, pull out a loop of wire about 18 inches long and tape it off with electrical tape, so that you have enough wire to work with at the valve box when you are wiring your valves. Run the wire to the location of the controller and leave enough extra wire at the controller location to make proper connections. With the multi-strand wire, it is important to use a single run of wire from the controller to the last valve on the run. You don't want to have to splice all of the wires in the multi-strand cable somewhere in the middle. Not only is that time consuming, it is a complex service call just waiting to happen. Pipe and wire should be installed below the maximum depth that could be disturbed by soil aeration or other routine landscape maintenance. Most contractors aim to install mainline pipe and wire a minimum of 12 inches below grade and lateral lines a minimum of 8 to 10 inches below grade. There are two main methods for achieving this depth. You can dig open trenches or pull the pipe with a vibratory plow. The method used in your area will vary based on soil conditions and local practice. Open trenches can be dug mechanically with a trencher or by hand with a flat spade and trenching shovels. Open trenches allow easier access to pipe and wire during installation, but create greater damage in existing lawns than using a vibratory plow. Once the pipe has been installed, trenches should be backfilled and then compacted to prevent settling that might result in low spots. The two most common types of pipe for irrigation systems are PVC and polyethylene tubing, called poly for short. There are advantages and disadvantages to each, and the choice often boils down to local practice and contractor preference. PVC pipe is rigid and can accommodate higher flow rates than the poly pipe with the same diameter. Connections are made using solvent weld pipe cement and fittings that fit onto the outside of the pipe. PVC fittings that are welded to the pipe are called slip fittings. Those with iron pipe thread, IPT, are threaded. Many fittings are slip on one side and threaded on the other. When solvent welding two pieces of pipe together using either fitting, you should follow the solvent manufacturer's instructions. Some solvents require applications of a primer. Others use a one-step method. In general, cement is applied to both the outside of the pipe and the inside of the fitting that will be receiving the pipe. The solvent cement softens the joining surfaces to make a chemical bond. Here's some quick tips for welding pipe together. Use an adequate amount of solvent on joining surfaces, avoiding a dry socket connection that fuses improperly. And wipe off excessive solvent from the joint to allow it to cure properly. Polypipe is more flexible than PVC, but has lower maximum flow rates than equally sized PVC. Its flexibility allows for curved trenches. Its rolled form allows longer runs between connections. Polypipe is generally connected with insert fittings, which are barbed fittings that slide inside the pipe and are secured in place with clamps. There are also clampless fittings and tapping saddles for polypipe. Ask your distributor for information on these. The most common fitting used in irrigation are T's and elbows. T's are used to create branches in either a main line or lateral line. Elbows are used to turn corners. Male and female adapters are used to take pipe to threaded connections. Couplings are used to connect two pieces of pipe together. Reducing fittings, couplers, T's, and elbows, and or bushings can be used to change pipe sizes. Finally, there are a number of specialty fittings used to connect sprinkler heads to the lateral lines, including fixed length risers, cutoff risers, swing joints, flexible swing assemblies, and more. Your local distributor can guide you to the options that work best for your area. When connecting sprinklers to the pipe, combination threaded T or tapping saddle is used. When choosing locations for your valves, you may wish to group them in one location or install each remotely around the landscape. Manifold systems offer service convenience and less length of mainline. Scattered valve systems reduce the amount of lateral line. Review your plot plan to decide which makes sense for your system. There are a variety of pre-made manifold assemblies available to aid installation when valves are grouped together. These assemblies space the valves evenly and often come with an easy way to detach a valve for service or replacement. Valves should be installed in the appropriate sized valve boxes for future locating and service. To install a valve box, the first step is the evacuation of the valve box area before the pipe is put into place. Dig out enough area so that the valve box fits securely in place, such that the top level is level with the grade. It is recommended that you pour 2 to 3 inches of pea gravel into the bottom of the valve box to facilitate drainage. After the pipe has been pulled or laid in place and the valve or manifold has been installed, set the valve box on top of the manifold in the desired orientation, and note or mark where the pipes will enter and exit the valve box area on the side of the box. Next, cut out notches in the side of the valve box for pipes to pass through and fit the box over the valve manifold. With the valve box lid on, use soil to backfill around the valve box and compact the dirt to prevent settling. If the valve box is an established lawn, cut the sod that has been removed and fit it around the box to create a crisp, neat appearance. When installing valves, note the arrow on the valve indicating the direction of the flow. If the valve is installed backwards, it's not going to work properly. Valves can be purchased with slip inlets and outlets, threaded inlets and outlets, or with a threaded inlet and barbed outlet to match the type of pipe and manifold connections being used. To make wire connections at the valve, begin by removing the jacket from the multi-strand wire. Score the jacket on both sides and bend the wire to break the jacket. Pull the jacket back to expose the wires and find the string inside among the strands of wire. Pull the string to cut away the jacket so that you have 12 to 8 inches of exposed wire to work with. Each valve must be connected to 2 separate wires. All of them get connected to the white common wire, and each gets connected to one of the colored zone wires. At each valve, include an expansion coil of excess wire for future service. To make this, wrap 6 to 8 inches of wire around a piece of pipe in a coil before making the connection. Then, withdraw the pipe. This coil leaves extra wire for future splicing or movement and keep the valve box looking neat. To make a specific splice, follow the procedure noted on the package for the wireproof splice you are using. You will want to closely follow the amount of jacket to be stripped and how to twist or snap on the waterproof connector. It is extremely important that all wire splices are made properly to avoid future service issues. Depending upon local climate and local practice, the irrigation system will commonly connect to the municipal water supply at one of 2 different locations, depending on the location of the water meter. Now, if the water meter is in the basement in a freezing climate, the connection will be made there and then piped through the wall to the backflow preventer. If the water meter is in the yard, in a box or meter pit, the connection will be made near there. In all cases, a separate shutoff for the irrigation system should be installed at the point of connection so that the system can be serviced without needing to turn off the water supply to the house. Identify the size and type of the line coming from the meter to determine what size and type of fittings to use. Remember in some cases that these connections will need to be made by a licensed plumber. A backflow preventer is a required element in any irrigation system connected to city water. Be sure to check with your local agency to determine the device needed for your area. There are 2 common types of backflow preventers used with irrigation. The first is a pressure vacuum breaker, or PVB, that must be installed at least 12 inches above the highest outlet on the system. The second is a reduced pressure principle, or RP, which must be used in applications where a change in elevation on the job site leads to parts of the irrigation system that are higher than the backflow preventer. An RP must be installed at least 12 inches above the ground. When installing the backflow preventer, once again the direction of flow really matters. Make sure that the flow arrows are pointed toward the rest of your irrigation system. If they're not, well then, no water will be able to pass through the backflow preventer. The controller should be installed in an easy-to-access location near a power source. For an outdoor controller, use conduit to protect all wiring going to and from the controller. There are knockouts on the bottom of the controller to accept the conduit. Use appropriate wall anchors to secure the controller based on the instructions provided. Outdoor controllers are typically hardwired into an electrical circuit. In some areas, it is acceptable to connect to a waterproof outlet with an in-use cover. Check with your distributor on the requirements for your area. Indoor controllers should also use conduit to protect wires coming from the outside to the controller location. Drill through the exterior wall to run the conduit and the wire. Follow the manufacturer's instructions for wiring the controller. Most use a terminal strip for connection of the zoned wiring. To use this, loosen each set screws. Then, strip about ½ an inch of the wire jacket off. Insert below the screw and then tighten. Remember to keep track of which color wire corresponds to each of your zones in the field so that you can set up an organized sequence at the controller. Program the controller using the user instructions, taking care to set watering times based on the type of plant material, sun exposure, and soil type for each zone. A rain sensor is an essential part of a water-conserving irrigation system to interrupt automatic operation during wet weather. Rain sensors come in both hardwired and wireless versions. The advantage of the wireless version is that you don't have to run the wire to the sensor location. The disadvantage is that there is a battery that will need to be regularly changed. When mounting a rain sensor, be sure to mount it above and away from the spray areas of the irrigation system, and check to see that it is not obstructed by an eave of a house or tree branches. Rain sensors are often mounted on a gutter of the house in full sun. To wire the rain sensor, simply strip the 2 wires from the sensor and insert them into the ports labeled Sensor in the controller. There is usually a jumper wire in that location when the controller comes out of the box. Remove it as directed in the instructions. If there is a switch or programmable feature that turns the rain sensor on, make sure that it's in the on position to have the sensor active. Kind of a no-brainer on that one. Once all of the pipe connections in the system have been made and before installing nozzles in the heads, it is important to thoroughly flush any dirt or debris from the lines. Debris from the installation in the pipes can easily get stuck in valves and heads, causing them to malfunction. Pipe shavings are common culprits for problems at system startup. Flushing the system is especially important for spray heads, which are easily clogged. That's the reason why they come with a flushing cap pre-installed. Only install the nozzles after the system has been thoroughly flushed. However, if debris gets caught in the valves, you can take the top off the valve and clean it out. To flush each zone, unscrew the sprinkler head from the sprinkler body at the end of each lateral line. For end-fed zones, this will only be 1 head. For zones with a T or T's, there will be more than 1. Run the zone for several minutes until all the dirt, pipe shavings, and other debris are flushed out and the water runs clear. Once the zone is thoroughly flushed, replace the sprinkler heads and move on to the next zone. For drip zones, open the flush valve at the end of the zone and be sure to clean out the filter in the control zone after the system flushing is complete. Once the system has been thoroughly flushed, it's time to install the nozzles and make preliminary adjustments to the sprinklers. Consult the plot plan to ensure that each sprinkler head receives the proper nozzle. It's crucial to pay attention to the nozzles on the rotors to ensure matched precipitation in the watering area. Here's the basic idea, folks. On a single zone, if there are both quarter circle rotors and half circle rotors, the half circle rotors should have nozzles with twice the flow rate of the quarter circle rotors. So if your quarter circle rotors have a 2.0 gallon per minute nozzle, the half circle rotors should have a 4.0 gallon per minute nozzle. If the nozzles are not properly matched, the sprinkler system will have an uneven coverage, leading to dry spots on the lawn when the lawn gets taxed during the hot, dry summer months. To adjust part circle rotors, the first thing to do is to find the fixed stop for that rotor, either on the left or on the right side, based on the manufacturer. You can spin the head manually to find out where the stop is. Align this stop with the desired edge of the sprinkler spray area. To adjust the other stop, use your sprinkler adjustment tool to make the arc wider or narrower, based on the desired watering area. You can spin the head back and forth to check the stop points. To change the nozzle, use the adjustment tool to lift the head and loosen the set screw in front of the nozzle, allowing you to pull out the old nozzle. Select the appropriate nozzle from the nozzle tree, insert it into the rotor, and retighten the set screw. Some rotors have a radius adjustment on the head of the sprinkler. You can increase or decrease the throw of the sprinkler using this tool. Some contractors will crank down the set screw in front of the nozzle to reduce the radius of the sprinkler. This is not recommended, however, because it will compromise the spray pattern and can lead to uneven watering over the spray area. Spray heads have a ratcheting pop-up head that allows you to twist the head to direct the nozzle in the appropriate direction. For adjustable fixed spray nozzles, there is usually a line marking the fixed edge of the spray pattern. The size of the arc is generally adjusted by twisting the sides of the nozzle. You can increase or decrease the radius of the spray by tightening or loosening the screw in the middle of the nozzle's head. Rotary nozzles are adjusted in different ways based on the manufacturer. Again, there's usually a line marking the fixed edge of the nozzle, which you can align with the edge of your spray by ratcheting the spray head into the desired position. You can adjust both the arc and the radius of most rotary nozzles. Once the system has been completely installed, do a final walkthrough to make any last-minute adjustments to the nozzles and to ensure that all zones are working properly and are covering the entire area to be watered. Advance the clock through each zone and inspect the sprinklers. Make sure that the rotors and nozzles are adjusted so that they cover the entire area to be watered, but do not spray onto pavement, hardscapes, the house, or any other locations where overspray is undesirable. Once you have walked through each zone in the system and the system is off, listen to the backflow to make sure that there is no water still running, indicating a leak, and turn the clock onto auto before you go. Job site cleanup should be happening throughout the installation. It's easiest to rake or sweep up dirt before you turn the water on. But on your final walkthrough, keep an eye out for trash and equipment that you might have left behind and clean up any landscaping that has been disturbed. A final step in the installation process is to note any changes to the plan made during the installation, creating an as-built plan that you can keep on file to be consulted during any future servicing of the system. Nice job! With this, your installation of a residential irrigation system is complete. I'm very proud of you.